All right, welcome everyone to the seminar. So today we are opening up a more external series of seminar for the QT Center for Robotics. So welcome to QT for those who are connected from the outside. I'm Thierry Peno. I'm the senior seminar convener for the series here, and also an associate professor at QT, and also vice chair of the IEEE Queensland Robotics and Automation Society, which is co-sponsoring that event. And it's my great pleasure to start the series with Peter Corke, who doesn't need much introduction. I think some of people online, well, most people even online probably heard about Peter. Peter has a long list of achievements that I'm not going to detail. He's obviously a distinguished professor here at QT, probably the biggest name in robotics in Australia and one of the star of robotics in the world, and he has lots of passion, and one of them is teaching robotics to people, and you'll see how he got to do that and reach out millions of people around the world. So I'm really excited to give the floor to Peter.
Thanks very much, Thierry. Let me just get myself organized here, share my screen. All right, thanks everyone for coming. What I'd like to do in this talk is tell you a little bit about what I've done in the area of robotic education. As Thierry mentioned, it is my passion. It began a very long time ago. So I'm going to quickly whiz through some of the history of what I've done, be some sort of observations about what I think it is we need to teach people about robotics, and then onto some future work, current work and then future work. I guess the title of this talk is a bit different to what a lot of people on this floor are doing. On this floor is full of people who are humans who are teaching robots. And I wanted to talk about how humans can teach robotics to other humans. I do need to make some disclosures. I'm going to talk about MATLAB and Simulink, software tools. I'm a paid consultant to MathWorks, the publishers of those tools. And I also receive royalties for a book that I authored that I'm going to talk about as well. So full disclosure. So to start, I really believe that robotics will be a transformative technology in the coming century. And you can find all manner of reports written by smart people like McKinsey's who say, you know, it's going to be a $1 industry over coming years. There are a lot of things that robotics appears to make sense for, profound problems we have in society around an aging demographic, around food production, and so on. Robotics, like almost all technologies, will probably create profound problems of its own. And I think that's an important area when we're teaching roboticists, is to get people to think about what can go wrong in the area of robotics and how we can ameliorate those negatives. But if it is going to be a transformational technology, as I believe that it will, then we're going to need to train large numbers of people to create the robot systems. And if you consider an analogy with computer science, and whether this is a valid analogy or not, I don't really know. But you know, computer science really started in 1953, the first diploma out of Cambridge University. And the first CS department was born in the early 60s. And now, you know, almost every university in the world will have a computer science department. The US graduates 60,000 computer scientists every year. So around the world, hundreds of thousands of computer scientists graduating every year to support a computer industry, which really grew from nothing in the late 1940s to computers being everywhere today. So if we believe that robotics is going to follow the same trajectory, it's just 50 years behind, then we're going to need to produce lots and lots of people who understand about robotics. So that's my assumptions. That's my starting point. And we can have an argument about that if we'd like to later on. So my own journey in teaching robotics really began in 1992. And my first robotics project I ever worked on, I was a young research scientist at CSIRO, was a robot programming system. And it seemed like I've spent my whole life writing robot programming systems over and over again. I think I get better at it over time. And I sunk years and years into this project. It was all based in C language. But when it came time to have conversations with CSIRO management about open sourcing this, making it available to other people in the world, it was no, I could not do that. Open source wasn't really a thing. CSIRO is a very risk-averse organization. So although I spent years and years writing the software and used it internally, we used it in-house, it was a fail. It really didn't go anywhere, and that was kind of disappointing. I started my PhD kind of late in life. I was in my 30s when I started my PhD, and there's a Puma robot in the background, my favorite robot. And in this project, I started writing code in MATLAB. This function here from 1990 is still in the robotics toolbox. And there's some early quaternion code here. So during my PhD, to support my research, I started writing lots and lots of bits and pieces of MATLAB code. And it got to be, you know, quite a comprehensive collection of functionality to support robot kinematics and dynamics and what have you. In 1996, a couple of things happened. I was invited to my first ever International Symposium on Robotics Research, which was held in Germany. And all the great and the good of robotics go to this particular conference. And I took my embryonic toolbox on a laptop, 1996 laptop, there, and I showed it to a few people, and they were enormously supportive. And at that point in time in my career, I had a really good mentor, Hungarian guy, Laszlo Nemes. He was a bit of a rebel, and he just said, I should open source it anyway, just do it by stealth. And so the code ended up on an FTP server, which was a thing in the 90s. It's where you put code. I think the web hadn't been invented yet. And the manual got a bit more sophisticated. The toolbox probably got more sophisticated. It had a manual, and I published an article in the Robotics and Automation magazine very early on in the history of that periodical. So this was a good thing. Finally, the code, some code that I worked on was out there in the world. And the manual became more and more elaborate. That's the OCD part of me. And it became to look sort of more tutorial in nature. It actually started to look a bit more like a book. And so people said to me, why don't you turn the manual into a book? So you could have a book and a toolbox, and they'd be a pigeon pair, and it would be really good for education. So in 2003, I tried to do that. I think what I didn't realize at the time is that to create a book is an awful lot of effort. It is not something that you can do in the crack. So I tried, but I failed. I did not write a book in 2003. The book was remained in my head, but it wasn't rendered to paper. But almost at the same time, I got approached by a guy called John Craig. John's written a number of editions of a robotics textbook, probably one of the more popular robotics textbooks in the world, certainly sort of over the 80s, 90s, and noughties. And he wanted to use my MATLAB toolbox to support the exercises in the third edition of his book. There are two issues with that. One is that he uses this kinematic notation called modified Denevert-Hartenberg parameters. Some of you may know that thing. I'm not sure the world really needed another form of kinematic convention. But anyway, John put it into the world. So I had to modify my toolbox to support that. That was probably a useful thing to do. But at that point, I needed to sign a letter with the publisher, it was Wiley, to say that I would make the toolbox available for the book. I worked for CSIRO, so I had to take the request from Wiley to the CSIRO lawyers, management, and they said no. I thought, well, okay, maybe there's another way to do that. So we had lots of discussions. In the end, CSIRO made a legal agreement with me to say that this work was now mine, not CSIRO's. Because CSIRO, like most employers, own everything you do, night and day. Everything you think is owned by your employer. So I had a piece of paper that says the toolbox is mine, all mine. And that was really, really helpful. So a little time later, I decided to leave CSIRO. It was a very long move from CSIRO to QT. I had all this long service leave, so decided to spend it traveling and writing. I was finally under the book. So we moved to Paris and spent 3 months in a tiny little apartment in Paris and did a Hemingway thing. I could write book all morning, and then in the afternoon we'd run around Paris and France, and I'd take my draft with me wherever. This is me reviewing a draft of the book in Monet's garden, me reviewing a version of the book in Luxembourg Gardens. It kind of went with me everywhere. It was a total obsession, and it was for the 3 months in Paris. And then I went to Oxford for 3 months, hosted by Paul Newman. And it occurred to me as I was about to go to Oxford that they're kind of the preeminent mobile robotics group in the world. And I was writing a book about robotics that had not a thing about mobile robots in it. a bit embarrassing. So anyway, it forced me then to start to think about how I would explain mobile robotics. So a whole part of the book was born while I was at Oxford. And that was very useful. And I then had to create all of MATLAB functions to support that part of the book into the toolbox. So all that stuff happened in an enormously productive 3 months at Oxford. So from 2009, when the writing happened, 2010, dotting I's, crossing T's, book didn't come out until 2011. There was a party at IROS 2011. Lots of people came. It was a cake shaped like the book, which was very nice. And there was toast, there was champagne. It was a good party. So anyway, the book was out. The year before that was when Gordon and I came to QUT. There is this quote attributed to us saying we're going to do robotics in a big way. I think we have. We've got lots and lots of people, and we're ranked the #1 robotics research organization in Australia. There was a lot to do when we arrived in 2010, because there really weren't any robotics courses on the syllabus at all. So we had to create them. And so in that first 18 months, we designed all of these courses. And many of you here probably still, it's annoying, that bar at the top. Can I hide it? How do I hide it? Beautiful. Thank you, Serena. So many of you are probably involved in teaching or tutoring these units. They were all designed in 18 months. And an ironic thing is, before I came to QT, I was worried about doing too much teaching. So I had these words put into my contract. And honestly, today, the thing I most like about being here is the teaching of the undergraduates and working with PhD students. So 2012, some of you might know this thing on the screen. There we go. All right, 2012, a week before I was supposed to start teaching, I fell off my bike. I broke my knee, which is painful, and I had wires and pins put in it. So that's very definitely a fail. So I had to narrate my videos and upload them, and then Michael kindly presented them to the class, and we muddled through the semester. The end of semester, I put them all on YouTube and didn't really pay it much heed until maybe a little time later, I noticed that there were a stupid number of people had watched them. And that seriously made me think about reach. Because if we need to train so many people in the field of robotics, and I can teach 80 a year here at QUT, it's not going to work. I can't reach enough people. Where if I can now start to reach hundreds of thousands of people doing almost nothing, that's really very powerful. Now, at the same time, there was this movement in the world called MOOCs, massive open online courses, and the likes of MIT and Harvard said, you know, we've got the best professors, the best learning resources, we can put it all online for free, teach the rest of the world, don't need any other universities, you know, it's just us. And it was interesting, it caused a lot of thinking within universities about how education could be done or should be done. You know, that original very optimistic views of MOOCs really didn't come to fruition. Most of them now are behind paywalls, which is kind of sad. So the initial enthusiasm, the philosophy about sharing knowledge really didn't come to pass. QT had really no background in MOOCs. Managed to convince management that we should do MOOCs. And so I work with an awesome group of people to prepare 2 6-week online courses. They only ran 3 times, but we reached probably 30,000 students in that time, which is almost as many students as QT has, right? The very first course had 10,000 students. That's QT's first year intake. So the numbers are extraordinary. 1 professor and 3 tutors can teach this many people. It really does give you an idea about what's possible at scale. Now, the cost is extraordinary. So this video just shows some of the people who are involved in producing the MOOC. So there's a massive team of people over at Kelvin Grove who helped put this together. So learning designers and videographers and graphic designers, media people, photographers. It was brilliant. But what happened was that we ended up without a platform. So we went on a bespoke platform to deliver the MOOCs provided by a US company called Edcast. And QT made a decision to not continue with Edcast. So we ended up with 200 lessons that had been created with great love and attention and effort, ended up having nowhere to go. So yet another fail. So that then led to this thing called the Robot Academy. And what we did is we took the 200 plus lessons that were there in the MOOCs, we put them all online, all on YouTube, and we put a nice WordPress front end, which you can see here, which lets you view the videos. Yeah. So instead of, so it now is random access to the material rather than the MOOC. We have to wait for the MOOC to be scheduled, right? It's going to start in November, right? So I'll sign up for it, and you go through the material in a linear way that the creator thinks that you should learn the material. So it's actually quite restrictive. So with this, actually, I think it was a serious win, having the MOOC platform taken away from us, because now it's available to people anywhere in the world at any time. And there, if you want to do the linear structure, you can take these things called master classes, which are these 200 lessons arranged in linear order, and you can take them in 1 hour chunks or not. We've done a few updates since the Academy was launched in 2017 to make it accessible to people in China where YouTube can't be seen. We had to do some tricks, and there's currently a group of students in Brazil making Portuguese captions for Robot Academy. And Portuguese, I think, is like the 3rd biggest language group in the world. So that's interesting. So we ended up then with a kind of a stack of educational resources, from some toolboxes that I created and refactored over time to some books, 1st edition and 2nd edition, some random online notes and articles and tutorials that I write, and then some MOOCs, the Robot Academy, and some other resources, all powered by MATLAB. All of that stack of educational resources was written up by QUT, and it led to me winning the Australian University Teacher of the Year Award in 2017. So I got that very nice night out. So that was good, a kind of vindication for all the effort. And it really was quite an accidental journey to get to that point. So the thing that bugged me for a while was it's all based on MATLAB, and MATLAB's a proprietary language, right? My code's all free, but you can't use my free code unless you buy MATLAB from the MathWorks. And if you look at the language rankings, Python's number 3, MATLAB's number 16 or 17. It's pretty static there. So how hard could it be to rewrite all that stuff into Python? So I got approached by a random person, as often happens to me, Lewis, and in 2008, we were going to port it all to MATLAB. Sorry, MATLAB all to Python. Fail. It just kind of fizzled out. And then with a bunch of students, a few years ago, 2017, RoboPie fizzled out. It was a fail. We just didn't get far enough. We didn't have the momentum. So it's like with a book, you can't do it in a half-hearted way. You have to really hit it hard and intensely, otherwise nothing will happen. Okay, so that's the journey so far. Reflections about teaching robots and what's important. So I think, to me, this is the essence of what it is that we do as roboticists. We have mathematical principles, we express them in software, and we use them to control a machine to do good, right? That's what it's about. So if you unpack that, mathematical principles, these are the things that I think we need to learn as roboticists. And I think with the students that are coming our way, a lot of things are missing here. I think we're missing what I call spatial maths. So homogeneous transformations, quaternions, twists, abstract algebra, group theory, in particular, Lie algebra, those sorts of things are all missing. Graph theory, I don't think students do any of that. Linearization statistics and estimators. These are all the things that students should be quite familiar with if they're going to be doing robotics. Now, whether all this can fit into an undergraduate degree or it needs to go into a master's degree, don't know. Expressed in software. I think this is another area where our students are underprepared. I think they've got to have absolutely strong basics in object-oriented systems, programming. They need to know about real-time systems and concurrency. And you can know about multi-processor architectures, publisher, subscribe, client server, all that stuff, networking. And I think what I've put here in this different color, this is like a skill, a craft that they have to have. They need to be well-versed in Python, C, and MATLAB. They can't be blundering through. They need to understand it really well. We need to get them to that point. Control, probably not a very exhaustive list of things that they need to know from a control theory point of view. And they should be strongly versed in this tool, It's very, very powerful way of analyzing and designing embedded systems. And then there's the machine part. So there needs to be mechanical design, kinematics, dynamics. And they should have skills in CAD and 3D printing. They should be able to design and build stuff that works. So that's what I think they need to learn. And I don't think we, at the moment, do a particularly thorough job on getting all these skills on board. I don't think any university does. And there is also no notion of an agreed curriculum for students in robotics, as there is pretty much for computer science, particularly in the US. There's an agreed curriculum that's put out by the ACM, and most universities conform to that. In robotics, no, I don't think any country is leading. Now, once you've got all that under your belt, then I think you need some good experience with model-based design methodology. I think that's very important. Hands-on experience, actually just building stuff is really important. But there is a bit missing, right? This bit, right? And I think our students really need, and all of us actually need to learn more about this. We need to understand about human-centered design, ethics, and entrepreneurship, the people-y side of robotics. And that absolutely needs to be included. So there's some challenges. And I think the fundamental challenge as a teacher is, what order you do the theory and the hands-on stuff? And there's two schools of thought, and I'm not sure if one can be said to be better than the other. But one is, if you start with the theory and say the practice is coming, it can just be very demotivating to be experiencing a lot of theory. And the alternative then is to do the practical stuff first and get the students to just have a play, use their intuition, figure out what they don't learn, what they don't know, and perhaps create an appetite for learning. So that they're more receptive to the theory that will come later. Or maybe it should be in smaller steps and iterated. But I think this is a profound question for us when it comes to teaching. This is another thing that worries me a lot, is it seems quite socially acceptable to say you're bad at maths. You can be bad at, it's hard to say you're bad at anything else, but maths is socially acceptable. And I think that's sad, and it's certainly not very helpful. Another thing that I worry, and so I think the math strength of students who are coming into us today is not what it was. And I think the trajectory is going in a worrying direction. These are things that I worry about. I worry that people don't read books anymore. I worry, I'm a book author, so I'm invested in books. But to me, a book provides coherence, logical development of concepts in the right order. And books are largely correct. But everyone goes to the internet now for stuff. And on the internet, none of these things are true, right? You don't know if it's correct. The notation is all over the place. There's no order. It seems such a hard way to get knowledge, but it seems to be the way to go now. And I don't know why it is. I worry about things like Stack Exchange. I get another talk about Stack Exchange, where people just go and get answers to questions. Not learning, they're getting an answer to a question. And that's a very different thing. So these are some social trends that worry me. If you look at robotic textbooks, they're pretty heavy on maths. And if hypothesizing that maths capability is trending downward with time, then this is really problematic for learners who maybe don't have a good grounding, don't feel comfortable. They're going to see a page like this and just run, yeah? And if you look at many of the other books in robotics and computer vision, and there's a lot of them, they're all pretty mathsy, yet computer vision people and software people spend most of their time writing code. So it seems that there's a big disconnect between code and books. And many of these books have got software associated with them. You can go to the website, you can download the zip file, and then you're on your own, right? It's not at all integrated. If you look at a lot of software books, they do it quite differently. And these are some quite old ones, Koenig and Flower from '76. It's a mixture of text and chunks of code. And one of the LaTeX books is the same way. And this is a somewhat more recent book on Python for data analysis. It's prose and code all intermingled. And it's actually quite an old trend in writing from people who do software. And many of you probably never seen this thing, but there was a very famous document. An academic at University of New South Wales took the Unix 6 kernel, which was small enough to be understood and read by a human being, unlike the modern Linux kernel, and he mixed it with prose and bits of code from the kernel. So it was this big, thick book. I had like a 10th generation photocopy of it. But it was amazing. You could just read this thing. It was like a novel. And it would tell you how Unix starts up and how Init is born and how the file system works. It was fascinating. So it was this mixture of prose and code. And code's real, right? You understand what code does. Same as you can with maths. But more people are familiar with code than they are with maths. I might skip that slide. And I think I unconsciously absorbed this kind of style. So this ARCL project that I talked about right back at the beginning, fail number 1. The manual for that was written in a style that's pretty much the same as the style that I wrote my book in 2011, except I wouldn't use colons there anymore. So this mixture of prose and code, I think, is very powerful. And so the book, the first edition of the book, and second follows the same style, is a mixture of figures and prose and bits of code and bits of math, all in a continuous narrative. The code isn't up the back. It's not downloadable from an appendix. It's there. It's real. And you can cut and paste these bits into your own version of MATLAB. And I provide you all the code so you don't have to type it in again. And you can just make it work. I'm rabbiting on about something in this section. You can take the code. You can put it into MATLAB. You can run it. You can change it. There's some instant gratification there. If you want to know what's going on inside this function, you look at the source code and read it. So I think software is actually a very powerful method of teaching. And I think it's underutilized in robotics. One thing I want to mention is just about extraneous material in a book. My book's got a lot of extraneous material, and I think it's a thing you either like or love. This is a recent review from Tyler, and it's unfortunate about some minor typos. I guess as an author, you're always mortified about typos. Sadly, he didn't tell me where the typos were. He just said that they exist, which is kind of the worst possible feedback. I wrote to him, but I haven't got a reply yet. So what he said, apart from the typos, is he enjoyed reading the book. It's both entertaining and informative. And that's awesome, right? Because generally you don't think of a textbook as being entertaining. And so when I wrote the book, I did want it to be a bit entertaining. I mean, not dull, right? Not laughing, but not dull. And so to have someone say it's entertaining makes me very happy. There are all sorts of little anecdotes in here about some interesting characters around, and I'm not going to read them out there. And here's a little picture. It's actually a picture drawn by Isaac Newton out of his notebook about the spectral characteristics of light. And so I thought it's just nice to sort of put things in there like that to know that there are actually records of what Newton did and thought, and you actually see them, touch them yourself. I thought that was amazing. So take-home messages. It goes to books, it goes to MOOCs, it goes to lectures, it goes to everything. Good design and aesthetics are really important. If it looks like rubbish, people will think, justifiably or not, that you don't care. And so I think to make it look as lovely as you possibly can is really important. When the publisher asked me about the book, what was my #1 priority? It had to look gorgeous. And I think it achieved that. Software is a means of teaching. I think we don't take enough advantage of this. We can provide software to students, which they can use, but it's also got pedagogical value in its own right. They can look inside it, they can take it apart, they can change it and see what breaks. I think it's very, very powerful. Instant gratification is important. You can have a whole lecture of really abstract concepts, but if people can actually just run some code and see it do a thing, that's valuable. I really think it helps with the learning. The other thing I'll say, open source software is like a puppy. It's for life. And so if you put open source software out there, then you have to look after it. And you have to respond to people who find issues or bugs or whatever. And so for me, I have this ritual, which is every Sunday, I go through all of the things where I have content. So that's YouTube comments, GitHub comments, the user group for my toolboxes, the Robot Academy's got a questions forum. I visit all of these things once a week. So the worst case latency for anyone who uses any of my tools is 7 days, which is not bad. But there's a lot of software out there that's just got no support at all. It doesn't have a pulse. It's effectively dead and useless. So next bit. It's 2020. I started this thing way back in 1992. I got a prize that I need to spend. I got a handsome amount of cash. Python and MATLAB have still got the same relativity that they've had for a long, long time. So Python is just as important as it always was. And 28 years later, there is a PhD student creating a robotics toolbox. We could call him Jesse in Python. And so I guess I made the decision earlier this year that I would write the 3rd edition of the book in Python. Now, I can't do that unless I've got a Python version of the toolbox. So now 2 fails on that respect. This time it's going to happen. And so stake in the ground, the 3rd edition, which I'll start writing next year, will be done all in Python. So there's more stuff that's going to go in. There's bits of content that are missing, but all the software needs to be rewritten. So Robotics Toolbox of Python, it's a thing. Jesse doing the heavy lifting on that. It's got some fantastic graphics capabilities built in, a number of different graphical backends, a whole ton of capability that didn't exist in the MATLAB one. So the chance to not just port it, which is where was my initial ambition, but to kind of reinvent it almost, would be as similar as possible or as reasonable to the MATLAB code, not slavishly copying the MATLAB syntax, because that will drive Python people mad. So it's different. And it's layered on top of some other toolboxes. The spatial math toolbox, which is my passion project, is all to do with homogeneous transformations, rotation matrices, quaternions, and twists, and Lie algebra stuff. That's all in that Python toolbox. A graph class for Python, that's out. And then some of the examples in my book require Simulink, and there's no Python version of Simulink. So I've created a cheap and cheerful, good enough Simulink clone that will get me by for what I need in the book. So that's happening. And then there's going to be a second 3rd edition. And this is going to be done in MATLAB, but it's going to use all the MathWorks toolboxes, not my own toolboxes. So it's going to be this great array of toolboxes the MathWorks have been pushing out over the last 6 or 7 years. So this book will be based on these toolboxes. I'll have 2 co-authors on this book. The arrangements are not quite in place yet, but I hope within a few weeks I'll know where that stands. So not just 1 book, 2 books. Conclusions. All right, nearly at the end. From here in Brisbane, you can have global reach. Add up the numbers, I'd probably type something like 8 million people. They may not be unique, 8 million unique people, but in terms of all these different ways of getting content out there, 8 million people. On average, it's about 1 Robot Academy less than a minute. So probably taught 30 people while I'm standing here talking to you about something completely different, just as good as it gets, I think. My dream is for a much more exciting type of book. PDF is really boring. It's just like a printed page, but it's electronic. It doesn't take any advantage of what a computer can do or what a tablet can do, which is probably the way people would read it. So I want something that's in a tablet. The figures are all proper animations, Harry Potter style figures, if you like. I can change things in the book and the figures will change. Maybe it comes with a robot. It's from the book. You can type some things in the book and the robot will move. It's got a camera attached to it. Maybe you would look at it with a VR headset. I don't know. Anyway, this is edition 9 of the book. I'm only up to 3. I'm thinking about writing 3, but there's a lot more that we could do in terms of educational experience for people. Okay, last slide. Take home points. We need to train a lot of people about robotics. It's the theme I've been banging on about. The internet is a huge force multiplier. It really is. From here in Brisbane, instead of teaching just 80 students a year, I can teach potentially hundreds of thousands or millions. It is extraordinary. I never had a plan. This is all completely by accident. And there were numerous failures, but you just learn from the failures and you do a different thing. It was all really driven by external events and circumstances. So I'm happy where I ended up. But in 1992, I had no clue that any of this was going to happen. So thanks for listening. How are we going to do questions?
We have a few questions on the chat. Please ask question on the chat to start with. And if you want a verbal questions, just ask and we'll allow you to unmute yourself. I got a quick one just to start with. You had a number of slides with your aggressive fail stamp, the red stamp in there. Where are all the green success stamps?
It's a complementary set. I think I wanted to emphasize the fact that you can have failures. Failures are just part of life, and you need to pick yourself up. So that was the reason I think that I chose to highlight the fails. It doesn't mean the end. It just means do something different.
Because you're always in pursuit of the next thing. That's why you're thinking of the fail. But positive reinforcement is good too. So I'll just want to acknowledge all the successes there are in there, because there are plenty of them. So thanks for that. There was a question from Toby related to your point on the format, which is, do you think that Jupyter notebooks can work on a large scale? You can have text plus code plus math plus simulated robots all in the same spot.
You can, and I think Jupyter notebooks are one of the things I'm excited about with going to Python, and particularly there's a site called mybinder.org where you can actually put a notebook up and it's executable to anybody. They don't even have to have Python installed on their computer. They just need a web browser. And that's brilliant from an accessibility point of view, that you don't even have to have the code. And you can put plenty of great explanatory material in there. The maths is good, embedding images, graphics is good. There are a few clunky bits with Jupyter, but it's very definitely a powerful tool for teaching. And lots of academics do use it for teaching, and there are even tools that let students submit Jupyter notebooks with their solutions and auto-grade them. So there's a huge ecosystem around.
Michael has a question.
Hey, Peter, can you hear me? Can you hear me, Peter?
James had a question too.
Oh, we can't actually hear you, sorry.
Can you hear me, Peter?
Go to James's question.
Okay.
Just more a comment than a question. I think the whole idea of unbounded math is an interesting one, and I agree with it. I think it comes down to the fact that math is a very all-encompassing subject, broader subject of all the things we're talking about. I think it's more students don't know where to go. Not in the sense of they don't know how to get a textbook or anything. They don't know what to go to look up. They don't know to go to look up at spatial algebra and enhanced look up at like lead groups. Or
is it they don't know where to go, or is it they don't know what's the point of learning the thing?
They don't know. I don't know if they know the specific topics that we're going in the broad umbrella of maths necessarily. To go look it up, they just go, oh, I'm bad at maths. I'm not going to go look at maths anymore. But it's more that they don't go look at algebra, calculus, linear algebra, spatial algebra, stats, estimators. They don't know the specific thing to go look at for, rather than saying, so they just say, I'm bad at maths. That's my opinion.
Okay. I'm sure there'll be lots of viewpoints and opinions about why it is.
I think students would, I know I would appreciate seeing that all-encompassing one.
But that's about knowing where it is. That's about knowing the destination, yeah?
Yeah.
That if you know these things, then you could be a roboticist. I think at the moment maths is perhaps, you don't have that motivating example about why it is you need to know those things.
I agree.
Yeah.
Do you think like a course on constructive mathematics at an undergrad level would help a lot with the fundamental C for like engineers or something?
So what do you mean by constructive?
So constructive maths is a type of mathematics where basically the law of the square in the middle is not assumed. And as a result of this, it turns out that anything that can improve using constructive mathematics can be translated very simply into software algorithms. And so since a lot of like more applied people are better with code and understanding code better than what we normally think of as maths, I think teaching like a dedicated constructive mathematics course would help a lot for people in the applied areas of STEM.
It might do, but I think the important point you touch on, I think, is about the connection to software. I think people are probably more skilled in software and feel more comfortable being software people than maths people. maybe if you could bring those two things together, because ultimately anything you do mathematically needs to be implemented in software anyway. You can learn about software and about the mathematics by implementing the maths in software. So I learned a heap myself. So maybe that's something that we should be doing. So this is it's a very long conversation, I think, about fixing up maths in the world, but good to start.
Great question from Toby Walsh online. Another challenge is in our field is diversity. What have you learned about tackling this challenge?
I don't think I've learned much about tackling the challenge, sadly. Is about diversity.
Challenge in our field. Another challenge in our field is diversity.
I will. A fact is, if Google Analytics tells me the Robot Academy, the gender balance of users is equal, which is extraordinary to me. The demographic is mostly, 15 to 35 is the core demographic. Tails off a bit each side of that, but 50% female, which it's been consistently like that since the Academy was launched. So maybe that says that there's not an issue with there's no gender divide with the interest, but perhaps it is the way we present it or it's pictured at university level that makes it so unbalanced. That's just, I can only speculate about that fact. That's what Google Analytics tells me. But yes, diversity is going to be really important if we're creating robots to help society. Then yeah, those robots need to be created by a proper cross section of the society that those robots are supposed to help, and we don't have that at the moment.
The question from Michael that we missed earlier was a very inspiring talk, Peter. When you say no plan for people trying to learn from your experiences, surely there were enduring themes or principles you can point out to. For example, you were always finding ways to chip away at your toolbox and related activities regardless of the job you were currently in.
If there's any principle, I think it's about a passion or an enthusiasm. And so all this stuff is my hobby, is what I most want to do. So if it's what you most want to do, then it's never hard to find the energy or the motivation to do it. So I think it's just that alignment, that I'm a geeky person that likes writing code and fell into robotics. And so that's what I love doing. Teaching people, explaining things, I've discovered I really like doing. And so, and it's a motivation for doing the geeky stuff is, it can teach people. And through the Academy and all those social media forums that I've got, the comments that you get, the testimonials, the nice words that people say, thanking you for the effort you put in to create the tools. I mean, that's just fuel for the fire. It really is. So I'm very susceptible to flattery. You should all know that.
You touched a bit on MOOCs, how they appeared a few years ago, and only a lot of energy around the world, maybe the biggest thing that happened to education
Yeah.
in a long time. Now maybe it is not fulfilled the promises. Could you speculate a little bit, how would education at the university level look like in 10 years? Are we still doing lectures at universities or MOOCs?
I think MOOC. Yeah, so Nico's question is about what happened to MOOCs. There was a huge promise, but then they sort of fell by the wayside. I think the business model is important to the universities, and giving it all away for free didn't stack up. And I think that's why most of them have gone behind paywalls. Yeah, there's a free teaser, but if you want to do the test, get the certificate, or see all of the courseware, then yeah, you're going to have to pay money. I think universities would probably just have muddled along the way they had. There'd be some MOOCs in the world, but every university would have a lecturer preparing, the 101 course for every possible subject. And that's madness, because really only one person in the world needs to prepare the 101 course for each subject, then roll that out globally. There's issues around language groups, of course. But I think as class size, but what's missing is the human dimension connection. And that's why I think MOOCs didn't really take off. So yes, you could listen to the best person in the world telling you about subject X, yeah? And there was some social learning forum that was created where you could mix it with other students and the tutors. But I think humans being social animals, I think they want the face-to-face interaction. So I think universities will always have a place. I think what will change, students can get their learning from anywhere now. We know that, right? They don't come to lectures, they watch videos on YouTube, they find bad articles on the internet and they read them and absorb them. So they will scrounge for knowledge, if inefficiently, but they will. Some of them will read books, and that's nice. The universities will probably have a role in credentialing going forward. So at the moment we teach and we credential, we issue degrees, yeah? The learning one, the teaching one, that's shaky to me. The credentialing, I think universities will hold that for longer, but we're probably going to think about non-monolithic credentials. That's what people are talking about, micro-credentialing. So we might have to offer, you could just do a single course on kinematics, you know, and you get a badge or a micro degree or something like that. So it will change. And I think COVID has kicked that along because now we know that we can teach students, maybe not as well, using video conferencing technologies. And that's in its infancy. So I think next year, if we're still got the same restrictions we have now, we'll do a better job of teaching students remotely. That knowledge, best practice will be shared across institutions. We'll get good at doing that. So maybe students only come to universities for much more limited time, limited interaction. But I think they would still want to come. I hope they do. Yeah.
Do you think universities should teach how to get your knowledge from the internet in a proper method?
That's a good question. So the question is, should universities teach you how to forage for information on the internet? And I think they should, because the benefit for the students in their improved productivity, you know, critical analysis about, is this thing I'm reading junk? Does it stack up? I think that is important. And the only way you can find out whether something stacks up is to read lots of things and see if they're consistent. So you go to a book and read something once, or you go to the internet and read 7 different articles and say, yeah, there seems to be some kind of consensus. I think I get what's going on here. So they need to be more efficient. Yeah.
I think I saw you skip a little programming slide.
Yeah.
Do you think that should be taught at an undergraduate level as well?
So the question was about literate programming, and literate programming was a concept, I guess, originated by Donald Knuth a long time ago. And that's when you write a program, you actually write an essay. You write a story that's got words and text, words, text, prose, and code, right? All in one great big mingled narrative. You know, the software style that, the software writing style that I was talking about earlier. But with literate programming, what you do is you put this document through tools that pull out the code and compile it and pull out the documentation and turn it into a manual. But you write the manual and the code at the same time. I'm not sure it ever has achieved a lot of traction. It seems like a lovely idea, but it really hasn't taken off. But to me, it has a lot of merit.
I'll just take the last question in the interest of time. There's an interesting one to conclude on the chat, which I think was inspired by your title, unsurprisingly. What are major steps to go to see robots teaching robotics and knowledge gaps to people? Will and when it will be happening?
So the question is about, will robots teach robotics to humans?
Yes.
I think that would be sad. I mean, it's broader than robots teaching robotics. I mean, it's robots teaching anything to humans. And people have worked on computer-aided education, was a term from decades ago. AI systems for trying to track how students are progressing in their learning and adjusting curriculum online. All of these tools exist. I still think the human factor is important. And I would wonder if anybody who has children would want their children to be taught by a robot. So it's an interesting abstract question, but I think people wouldn't want it. And maybe I'm a dinosaur.
All right, thanks a lot, Peter, again
Thank
for
you.
the talk. That was pretty awesome. Thanks everyone for attending.